and just selecting among them.
As these terms apply to your hypothesis, what do you mean by sort of self-organization you've described, but
you had brought in self-assembly and the distinction between...
Many scientists say the terms self-organization and self-assembly are interchangeable. Some say the snowflake forms by self-organization. You call the snowflake formation process self-assembly. Some scientists describe the self-assembly of the hydra, for instance. You did extensive experiments with the hydra in the early 1970s in England at the University of Sussex, and you term the hydra's regenerating process self-organization. To what do you attribute the difference in use of these terms self-organization and self-assembly? And what do you mean by self-assembly?
Okay. So self-assembly is an area of, it's really come out of chemistry and physical chemistry. So molecules can undergo a process of self-assembly, and it depends on the shapes of the molecules. And very often you see self-assembly where you have a number of identical or nearly identical subunits, and they come together and they form structures that have certain variable properties to them, but certain common properties. So because of the molecular nature of water, it will crystallize with certain symmetries, and when it forms snowflakes, they'll always have six-fold symmetry, but every one of them will be different from the other. This is a self-assembly process. It's not a process that where the form depends on a flux of matter and energy. It's you have subunits coming together, and it's generally considered an equilibrium process. Some of self-assembly processes utilize some energy, but by and large, self-assembly is reserved for the equilibrium processes, and you get static structures. So a snowflake, as long as you just keep it cold, it'll stay there. It doesn't require a constant input of molecules and an expulsion of molecules. It's a static structure. Self-organized processes often require a flux of matter or energy just to keep the structure in place. So, for example, the physicist, physical chemist Ilya Prigogine, a Nobel laureate, who looked into the self-organization of matter, he called these things dissipative structures. They're structures that remain in place by using energy to stay in form. Okay? So many of the self-organizing processes are like that. They're dissipative structures. And when I talked about this process of generating the vertebral column, it uses chemical oscillations. It uses oscillations of molecules inside the cell. And you can't have an oscillation without expending energy and having a flux of material in and out of the system. You can't have a stationary oscillation without a flux through the system. So in that sense, it's a non-equilibrium system, but it generates, eventually it could generate static forms if the forms get frozen into place. So there is a big distinction from the point of view of physics and chemistry between self-assembly and self-organization. Now, I just want to hasten to say that inside the cell, there are processes of self-assembly. Many of the cytoskeletal structures, the structures that keep the cell in shape internally, are made up of proteins that self-assemble. So microtubules, microfilaments. You have identical or a collection of a small number of subunits, and you have many copies of them, and they will form very, very long, extended structures. But those molecules had to evolve to be able to self-assemble. You can't just take any old molecule and expect it to self-assemble. So the self-assembly that you see inside the cell is a function of subunits that have evolved to self-assemble. So self-assembly per se can't explain evolution. It's really, it happens in the physical world, but when it happens in the biological world, the units that self-assemble are products of evolution.
Is it because self-organization is so misunderstood within the biology community that you've tucked it under the umbrella term phenotypic plasticity in the extended synthesis, along with epigenetics, plasticity being a concept generally understandable?
Yeah, so we had a summary from the Altenburg conference, and we just wanted to create a number of umbrella categories under which all of the things that we discussed could be subsumed. And the interesting aspect, self-organization is a process kind of imported from physics and physical chemistry. And its biological implication is that if you have an organism with a certain genotype, then because of self-organizing processes, which are subject to perturbation from the environment and so on, you can get different outcomes with the same genotype. So from the point of view of evolutionary theory, that is plasticity. That is the ability to make different forms from the same genome. So it wasn't important to kind of enforce every mechanism of plasticity. Plasticity was a sufficient umbrella to include those concepts.
Why do you suppose the mainstream media stonewalls coverage of self-organization when the National Science Foundation supports the investigation, including your own? The research is there. You're seeing things in the lab that maybe you didn't even see years ago. So self-organization is real. Why the media gag?
Well, don't know if it's kind of a purposeful gag. I think that in order to understand self-organization and not just, say the term, it really takes a certain level of sophistication in the physical sciences as well as the biological sciences. People can understand what a gene is and how a gene specifies a protein. Those ideas are easy to explain to the public. Ideas of self-organization are much more difficult to explain. And I just feel that the people kind of in charge of disseminating information don't understand the concept. It's even just the way many physicists don't understand biological concepts, many biologists don't understand these physical concepts. So there's kind of a two culture or even more culture problem in theories that are relevant to evolutionary biology. So I think it's a matter of just kind of people not understanding the concepts well enough.
To what do you attribute the reluctance to distribute literature about self-organization by organizations like the National Center for Science Education, which advises schools in America on what textbooks are suitable?
I think that there is a challenge that self-organization and plasticity in general presents to Darwinian theory. Because Darwinian theory is basically a theory of incremental change. And if you are confronted with a very complex structure, the